Today we are going to learn how to draw the diagram for telescope when the final image is formed at least distance. Okay, there are two types of telescope is there. One is a reflecting, another one is a refracting. Okay, reflecting have more advantage compared to the refracting. Okay, now we are going to learn the refracting telescope. So if refracting telescope it's required for the lens, reflecting telescope it's required for the mirror. Okay, now we are doing as a refracting telescope. Okay, we need two lens, one is the objective lens, another one is the eye lens. Okay, in this case objective lens is bigger than the eye lens. Okay, so because the field of view it's more. Okay, when we are using the telescope the field of view will be more, that is the reason objective lens is more than the eye lens. Okay, consider I placed as the object as the infinite, it's very long distance. Okay, so it is optical center and it is objective lens, it is a focal length of objective lens, and it is a 2 times of focal length, which one we can call center of curvature. Okay, it is 2FO, or we can take it as a C. Okay, center of curvature for objective lens. The same thing I am taken here, the focal length of objective lens and 2FO. Okay, imagine the object is placed behind C. Okay, or infinite. Okay, the parallel ray, the ray which is passes at center and immediately goes straight. Okay, the ray which is near to this, it will be formed like this, which one I am not going to use any of the rule. Okay, it's going to converge like this near to the focal length, it's going to converge here. When the object is behind C, the image will be formed in between F and C. Okay, in between F and 2F. Okay, the final image is formed here. Okay, AB is the object, A dash B dash is the image for the objective lens. Okay, now eye lens. Eye lens I am taken, the focal length of eye lens is called FE. Okay, which one is going to taken here? Okay, for the focal length of eye lens I am taken here. Okay, the final image is formed at least distance. The final image, the distance is called, we can take it as the final image is going to form at the capital D, the distance of least distance, which one is the 25 centimeter. Okay, which one we are going to call is the normal eye. Okay, the final, the image is formed infinite means we can take it as a relaxed eye. If the final image is formed at least distance means we can take it as a normal eye. Okay, the object is placed in between F and O, in between F and the optical center, focal length and optical center. Okay, so I'll draw here, when the object is placed in between focal length and optical center, it will be like this. Parallel ray will go through the center ray and it will go straight, it will be produced as a diverging ray, so both will be converged backside. Okay, so it will be the upright virtual erect image is going to produce. Okay, the same situation here, it is a focal length of eye lens, and here the optical center for eye lens. Okay, the object in between F and O. Okay, so that means final image will be formed at magnified and virtual. Okay, the parallel ray will go through the focus, which one is going to be FE, the focal length of objective lens. Okay, the center ray individually goes straight. Okay, which one is going to produce as a diverging ray. Okay, diverging ray always will be converge as a backside. Okay, diverging ray always converge as a backside. Okay, so the final image is formed here, which one I am going to take it as a dash B dash. Okay, the final image is formed at A dash B dash at the distance of 25 centimeter from the eye lens. Okay, so which one is going to form at least distance. Okay, so now it's O is objective lens, E is eye lens. Okay, FO is focal length of the objective lens, FE is the focal length of eye lens. Okay, here the object is placed behind 2F, in the image is formed in between F and 2F. Okay, in the second case the object is placed in between F and O, the image will be formed at it is virtual and erect. Okay, the final image characterization of reflecting telescope, it's inverted. Okay, and it's a virtual image. For this lens it is a virtual image. Okay, and also it is a magnified. Okay, so I am taken the final image A double dash B double dash. Okay, so the image is formed by objective lens, I am taken as a dash B dash. Okay, thank you for watching my channel. If you like my channel, please subscribe. Thank you everyone.